I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 13th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we have 3 gales in play. One in the northeastern Gulf of Alaska, which has produced swell, which is starting to impact northern California. Another system north of Hawaii that's just getting started. And another system pushing off the Kuril Islands, trying to generate swell, targeting Hawaii. Let's get into the details. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, a dip in the jet, sort of like right there. And, like right there. What that helps do is create a counterclockwise flow aloft and down at the ocean surface, and that's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, as they start radiating away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. Right, so we have 2 potential opportunities from a jet stream perspective. Let's put this into motion, see what happens. As we get into Monday, yet another trough develops in the, I'll call it the northwestern Gulf of Alaska. Not very strong, not a lot of wind pushing into it to get that circulation going. And the trough that was in the northeastern Gulf pushes inland. But notice the jet stream really starting to bloom, pushing off Japan with winds to 70 or 80, 180 miles an hour. That would provide good opportunity, assuming a trough were to form somewhere in that area over the long term. All right, so we get into, where are we here? Tuesday. Almost a trough trying to form north of Hawaii while the flow starts building off of Japan, pushing to the dateline Tuesday night. And then as we get into Wednesday, expanding a bit. Now notice, nothing really happening in the Gulf as we get into Wednesday night. It's the whole focus becomes the West Pacific. In fact, the jet becomes well split. Notice the split here with the most energy pushing east into Canada, but a good amount falling south to the equator and even south of there, and then some other sort of tertiary split with energy pushing into Baja. So not a well-organized pattern east of the split point. Anyway, so we're into Friday. No real troughs organized, but the jet almost completely consolidated. The split point just about gone as we get into Saturday. A singular jet stream with winds to 200 nautical miles an hour at 35 north pushing off Japan. So this gives us some hope long term that maybe we could be in for something, but it's hard to say. Now notice here we are. We'll just take it out to 180 hours. We're into Sunday night, almost Monday. Again, still 200 knot winds. The jet just raging. Not very organized, though, over the Gulf of Alaska. Mainly, this looks like an event, at least a jet stream event from the dateline and points west of there, but no clearly defined troughs as of yet. So let's go take a look down at the ocean surface. This is surface level pressure and surface level winds. We see weak high pressure protecting Southern California and maybe the southern part of Central California, but you can see low pressure up in the Gulf, 40 knot winds, generating seas, probably on its last leg though. A new gale developing north of Hawaii with 40 to 45 knot winds, and a far broader gale off the Kuril Islands with a pocket of 55 knot winds and other areas of 45 to 50 knot winds. So really, that would be a storm. As we move into Monday, the gale that was north of Hawaii lifts northeast with 55, almost 60 knot northwest winds. That certainly would get some traction on the ocean surface. And the system over in the far west Pacific kind of fragments, falls apart. We get into Tuesday, the gale in the Gulf starts fading. Looks like it's poised to push into somewhere, we'll call it British Columbia, while the system in the west starts falling apart. We know the jet is just ripping here for sure, but with no troughs, then there's no no ability to get that upper level circulation or the surface level circulation going. Now, supposedly on Wednesday, we get yet another small gale developing off North California with winds building to almost 50 knots. So again, for briefly a second, we'll call it a gale, not a storm, pushing inland Wednesday night, and a broad area of low pressure filling the, probably 60-70% of the North Pacific, but with no real organized fetch of any magnitude associated with it. Yeah, there's some 35, maybe 40 knot winds there, and yes, for sure, oh, there we go, 55 knot winds on Friday. So maybe something could spin out of that. And, I mean, this is actually, and another broad area 30 knot winds as we get in Friday night and Saturday. And then you see pockets 35 knots, 30 knots, 35, 40 knots. So there's multiple opportunities for something to develop, but nothing, cohesive, large scale. There's just almost too much wind energy and not enough troughing to really allow fetch to dig out. But still, it certainly doesn't look like things are going to go flat at all. Now we're going to look at the effect of those winds on the ocean's surface, but we're going back in time. We're going back to Wednesday, so what's that, 4 days ago? A gale developed here over the North Dateline region. Not a particularly strong one with 40 knot winds, something like that. 45 knot winds. Not winds, seas, 26-foot seas. Let's go back. There we go. Sorry, 24, 25-foot seas, building to 26 feet on Thursday, continuing there and then slowly fading out. The point being, swell from this system is starting to hit the Hawaiian Islands. There's some overhead surf at most spots along the North Shore. Nothing huge, but steady, rideable, clean surf. Then another gale developed on Saturday, and 36-foot seas, 35-foot seas Saturday afternoon, building to 38 feet or 39 feet, somewhere in there. Then on Sunday, it was fading out. This swell is hitting the U.S. West Coast now. It's just started in the past hour or two in Northern California. Outer buoys had some pretty decent-sized calculated surf heights, near 30 feet. So we'll see what happens overnight into the morning. The problem is strong south winds along the California coast and rain, at least in the Bay Area, and then forecast to be blowing pretty hard from the north by the morning. And then we get into our next system right there. Okay, that's developing, and this other system over in the west. So we're going into the forecast here now. The system here dies, but the focus is here and here. Little system north of Hawaii, producing 32-foot seas. The system over in the west, 35-foot seas. Then the system here north of Hawaii really blows up according to this most recent run of the model. 41-foot seas building to 46 feet, right there, 46 foot seas aimed off to the east, while the system in the west pretty much fade. This is on like midday Monday to 46 feet again, Monday evening. Continuing, you get the idea. Just a solid swell producer. Probably from Point Conception northward, it's pretty well to the north. And then we begin this pattern after that fades of this sort of fragmented areas of fetch developing. Another system off of California on Wednesday night, 26-foot seas. System in the Northern Gulf with 33-foot seas. And then fading out as we get into Friday. Another system supposedly in the Northern Gulf with 33, 36. Was that almost 40-foot seas on Saturday? But again, pushing well off to the northeast. And then yet more behind that. We'll just sort of roll through this because I don't really believe a model this far out, but it sort of sets the tone. Lots of surf expected, but not real well-organized systems as we get later in the forecast period. But hey, surf is surf. We'll take it. Anything counts. And then, believe it or not, we want to look south. Here's New Zealand, Southern Hemi. Notice the ice starting to break up. It's turning to summer down there, but still, and the models have been showing this for a while, a gale developing south of New Zealand. not impressive. This is on Monday night. But as we get into Tuesday, seas start building to 36 feet, right? 30, 32, 34, 30, 32, 34, yeah, 36 feet. And then it gets real interesting as we get into Wednesday morning with 42 or maybe 43 foot seas there, building to, now these numbers are for tropical systems up here, and I'm kind of ignoring that for the moment. It's 40, 42, 44, probably 45 foot seas under New Zealand, lifting kind of to the northeast. You get the idea here. And it's almost Christmas. It's very unusual to see something this strong. In fact, we'll just go blast through the whole thing one more time. I mean, and the models have been showing this for days now. They actually had it at like 53 foot seas at one point, backed off a little bit yesterday. Now it's coming back on again. So something to keep our eyes on the next few days. The net result could be southern hemi swell into Southern California at Christmas time. Hard to believe. A quick look at winds. So on Sunday, light south, we'll call it east-southeast winds over the Hawaiian Islands. Certainly glassy conditions there. California, it doesn't look as bad here on the chart as it was in reality, but pretty good south winds. We're all along in this area. And then we'll get into, here we go, into Monday. Front comes through, clearing high pressure, northwest winds 15-20 knots for most of the California coast. Relatively light trade still for the Hawaiian Islands. You can see the next storm pushing through the Gulf as we get into Tuesday. Maybe a better wind pattern north of Monterey Bay, and trades pick up a little bit for the Hawaiian Islands, 15 knots. Then we get into Wednesday. Looks like another south wind event for the Bay Area, turning northwest as we get into the evening. Trades continue for the Hawaiian Islands. Interesting kind of cutoff low thing here, pushing into, almost looks tropical in nature, forecast for the Hawaiian Islands. Anyway, into Friday, northwest winds, still pretty brisk for California. A east-northeast winds at 25 knots for the Hawaiian Islands due to that low pressure system. That'd be almost like a tropical low. And then Saturday, winds dying for California. Firm east winds for the Hawaiian Islands. We get into Sunday, north winds for Central California, but north of their pretty light wind regime. Trades, of course, pretty 15 knots for the Hawaiian Islands. Not too bad. And there we go. We're into our 180-hour projection. Quick look at precipitation for California. The good news is, yes, we have rain almost forecast down here to Central California, and snow in the Sierra. We'll talk a little bit more about that in a second. That dries out as we get into Monday. System tries to push into Northern California on Tuesday, doesn't quite make it. But then on Wednesday, another robust weather system produces snow and rain down into about the Point Conception line, snow for the Sierra. Then that dries out. Another system glances the northern coast, Cape Mendocino area, trying to push south into 180 hours out, but mainly limited to, we'll say, the northern part of North California. Now we'll zoom in a little bit more. We're looking at snow here. Specifically, this is the Sierra. This was as of 5 p.m. Sunday, and definitely it is snowing. Chain controls in effect up in the Tahoe region. As we showed before, that clears out. No real snow until we get into Wednesday, and then a pretty robust snow event for the entire Sierra. Winter is finally starting. Things clear out. And then we see if we got another one, not quite making it, all limited Northern California as we get into Sunday. And then perhaps Tuesday of next week, another snow event, not as big as what we are seeing right now, but still some snow, and then it looks like things pretty much dry out. The 10-day snow forecast for Squaw Valley, 36 inches about a week out, and then possibly up to 46 inches beyond that. Again, don't really believe a model that far out. Snow levels, this is the base of Squaw. This is the top of Squaw. Where the white line starts is the freeze level, so pretty cold for the next day or so, warming up a little bit, then falling back down for the Wednesday snow event, and then warming up for a while, getting cooler, and then potentially much warmer right before Christmas. Quick look at Kirkwood, pretty much the same picture. It's not that much further south, 3 feet, maybe pushing to 40 or 42 inches. Kirkwood, much higher. For the most part, snow level never going higher than maybe mid-mountain, so that's good for the snowpack there. And then further south, looking at Mammoth, so next couple of days, we'll call that about 9 inches, pushing to the maybe 16, 18-inch range, and if you believe the model way out, almost 2 feet, 23 inches, something like that. Snow level, much better, because here's their base elevation at 8,000 feet, and the peak summit at 11,000 feet. A little bit of push here, maybe a week plus out, getting warm about halfway up the mountain, but otherwise pretty cold the entire time. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, El Nino or La Nina. First off, we're going to go look for the active phase of the MJO. The MJO is a periodic weather oscillation, travels around the planet in part of it is active, the other half is inactive. It's the active phase that we're interested in. When it is traversing across the Pacific, it dampens trade winds and imparts energy to the jet stream. And if you get successive active phases and they're strong enough, they can reverse trade winds, and they can take warm water that's normally pulled up in the West Pacific, like over here, and push it to the east in the form of a ball of warm water that travels under the equator. It's called a Kelvin wave. Successive Kelvin waves can build up warm water off of Peru, and that can kick off El Nino. All right, so today we're looking at the arrows. This is the East Pacific here, this is the West Pacific here, this is the equator there, and the date line right there. We're looking at the arrows. These are 5-day average winds. You see they're out of the east, meaning strong trades in the East Pacific, continuing across the Central Pacific, and strong into what we call the Kelvin wave generation area when you get the active phase over in the West Pacific here. In this area from 135 east to 170 west, 5 degrees north and south of the equator. Really tight little area right here. When you get the trades to reverse here, that's how you can kick off a Kelvin wave. And that, and also impart energy to the jet stream if the active phase is strong enough. All right, so what we have in the West Pacific today is a little bit of strong easterly anomalies, but then they look like they're dying. Almost looks like maybe the active phase is trying to set up over the far West Pacific, and it hasn't done that for quite a while. But actually, it's the anomalies, differences from normal for this time of year. We see the trades, we see a couple little arrows sort of easing out of the east. So these trades, though they're strong, are not unusually strong, pretty much normal, continuing the whole way across the Central Pacific. Then you start approaching the Kelvin wave generation area. They build stronger than normal out of the east, so that would suggest the inactive phase of the MJO. But then you get in the far west Kelvin wave generation area, and you start to see some westerly arrows showing up, suggesting again perhaps the active phase of the MJO materializing. All right, what is the forecast, and what is this chart? This is the whole planet on one chart. This is the east-west component of the wind. Purples, like here, mean winds are stronger out of the east than normal, typically indicative of the inactive phase of the MJO. And the reds and the yellows are westerly anomalies. Winds stronger than normal out of the west, that would typically be the active phase of the MJO. All right, so the Pacific Ocean starts right about here. Okay, this is the Indian Ocean over here. And the Kelvin wave generation area goes from here to right about here. And here's where we are today. So we can see in the past, in November and early December, we had strong easterly anomalies, indicative of the inactive phase of the MJO. Then in early December, those east anomalies pretty much crashed. And you know what happened as soon as that crashed? The storm machine woke up. I mean, just even a slight variation downward in the strength of the easterly anomalies, it sort of took the cap off La Nina and allowed some storms to form. We had 2 very strong, solid, swell-producing storms, and that pattern supposedly is to be continuing until about tomorrow, and then the east anomalies start kicking up again, and that will probably, so we have a good jet, we saw that on the models, but notice we didn't get like really a lot of massive storms projected, and that's probably because of these eastern anomalies, especially in the West Pacific. So it looks like a building inactive phase of the MJO. So let's look at another dimension of the MJO, cloud cover. The active phase of the MJO produces cloud cover, right? It's like a low pressure system. The inactive phase produces high pressure and clear skies. So this chart basically, it's called outgoing long wave radiation. It's fancy words for cloud cover. The blues mean more cloud cover. The yellows, less cloud cover. The blues are the active phase of the MJO, and it is sitting, according to the statistic model, right where we want it to be, building in the West Pacific and forecast traveling over the Kelvin wave generation area. See, the equator's right there. There's South America, Central America, New Guinea. The date line's right there, 180 west. And so the Kelvin wave generation area is like right in there on all four of these frames. You see the active phase of the MJO pushing through the Kelvin wave generation area for the next 2 weeks. So that theoretically should be conducive to swell development. Now the dynamic model is not so favorable. That's the downside here. It has the active phase building, and then just kind of stalling and hitting and sitting steady. And not as strong as the statistic model. The truth is probably somewhere between the two. That's the way this normally works out. The dynamic model is too aggressive one way, the statistic model not aggressive enough, or vice versa. So somewhere between the two is probably what's going to happen. But let's keep digging. Next up, phase diagram charts. Same deal. This is the statistic model. This is the dynamic model. What are we looking at? See that circle right there? Assume that's the North Pole, and we're looking down on the North Pole. Okay, the MJO travels from west to east on the equator, from the Indian Ocean over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean, and goes round and round, okay? The dot is where the active phase is right now, so over the Maritime Continent, Bali. East Maritime Continent, so maybe more towards entering into the West Pacific. The further the dot is away from the circle, the stronger the active phase is. So this is pretty weak. When you see the dot out in here, it's very strong. So weak active phase, and these are the three projected tracks for it, all moving into the West Pacific, but two of them saying the active phase getting very weak, crashing into the inner part of the circle, but one suggesting, hey, maybe a moderate active phase setting up. The dynamic model has the same starting place, but it just has the active phase crashing, weak, staying completely stationary, and not making any real, well, maybe a little bit of progress to the west and then moving back. So somewhere between the two of these is probably the reality of the situation. So this is upper level precipitation. Yellow is not favorable for precipitation. Green's favorable for precipitation. And this is a strange one. Well, I can see what the problem is here already. It's December 6th. And what are we today? The 10th or something like that? The 13th. So we're going to discount this and just completely pass over this chart. And that takes us to the CFS model. All right, again, the whole planet on one chart, the date line, 180 west, running right up the middle. The Pacific starts about here, 135 east, to about the Kelvin wave generation, at least to 170 west right there. And then Ecuador on the equator is about 80 west, so somewhere over there. Here's where we are today. The blues, easterly anomalies. Notice this red here, that's an equatorial Rossby wave, maybe helping to generate a little bit of westerly anomalies in the Kelvin wave generation area, but within a day or two, that's gone. You see easterly anomalies redeveloping, filling the Kelvin wave generation area, but not nearly as solid as what we saw like up in here or any of this time from October onward. A lessening footprint of easterly anomalies, and then this solid black line right here, that is the active phase of the MJO, forecast to move through the Kelvin wave generation area somewhere, let's say maybe December 20th through maybe January 1st, so over the Christmas holidays. There might be a wind, but notice, no westerly anomalies forecast with it. This is pretty typical of La Nina. And you say, La Nina, and what's going on? We'll see the purple dashed line here. That is a high-pressure bias. Okay, that is the hallmark of La Nina, is high pressure over the Kelvin wave generation area. So even if you get, see the active phase, sort of, it actually connects here. The active phase traversing over the Kelvin wave generation area. Normally this would be all full of the reds and westerly anomalies, but the base state is a La Nina state, this high pressure bias, and it pretty much just kills the active phase when it traverses over. We'll see how this plays out, but the good news is, notice the width here. See if we can do this. The width of the purple contour is, in this version, getting smaller over time, even though there's two contour lines. This at least suggests that maybe La Nina to be weakening as we get into January. Hard to say. Let's go look at another chart. And then finally, the 4-month CFS forecast. All right. The past performance is down here. The future is up here. The thing that draws our attention is red and yellow in the January time frame, right when the active phase is supposed to be happening. Yellows and reds are westerly anomalies. That is maybe a very good sign here. So we'll overlay the MJO. Hey, sure enough. All right, so where we are today, December 13th, dotted contour, inactive phase of the MJO, easterly anomalies in control. Kelvin wave generation area starts right about there. So this and it ends right about here. So this inactive phase is almost over with. The active phase develops December 21st, roughly, maybe even earlier, and pushes through the Kelvin wave generation area into, according to this, to January 22nd, with strong westerly anomalies forecast on the dateline. That's probably overhyped, but it sort of gives us some hope. And then, of course, we pay the price. Just like El Nino La Nina, active phase, then the inactive phase comes in the dotted contour. Strong easterly anomalies filling the Kelvin wave generation area. But then as we get into the February time frame around Valentine's Day, a pretty broad active phase is forecast with some, we'll call modest westerly anomalies. You go, look at that, that's great. But the reality is the West Pacific doesn't start till right about here on the chart. So most of that's in the Indian Ocean. And as it traverses over where La Nina is, where the high pressure bias is, it takes some of the wind out, the west wind strength out of the active phase's sails. Okay, with that, let's overlay the low pass filter. So here we go, dotted contour. This is the La Nina signature. Right now, here's where we are. Forecast building to with a third contour starting tomorrow. Pretty much holding for the foreseeable future. No sign of this thing getting skinnier, moving out of the way, or doing anything in this model. And the solid contour is the low pressure bias that we would love to see in the Pacific, but it's over the Indian Ocean. So this is the hallmark of La Nina. High pressure in the Pacific, low pressure in the Indian Ocean. Of course, all this suggests is that the Indian Ocean will pump this summer. And that would be the focus of, if you're taking a summer trip and COVID's not in the way, that's where you'd go. All right, so that's kind of that. All right, enough of the MJO discussion. Let's go on and start talking about El Nino La Nina and what's happening subsurface in the ocean. Again, data from the TAO buoy arrays, a series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. But see these little X's? These are the anchor lines on the buoys. These are sensors on the anchor lines. They collect data, temperature data, centigrade temperature readings, and then we use a model to fill in the gaps. What you see is the 29 degrees Celsius isotherm at about 160 east. That's where it was last week. The 28 degree isotherm at about 170, trying to make a little bit of eastward progress to maybe 175 east. So maybe moving a little bit to the east. The 24 degree isotherm, so we had a finger, at least in this model, that pushed it out to about 120 or 125 last week. It's back to 140 now, and this is about where it's been pretty much the entirety of the winter. So what you do see is warm water in the west and not so much warm water in the east. That's driven by strong trades. We saw the trades pushing from east to west. They create upwelling here, make the warm water pool much shorter or smaller, and that is the hallmark of La Nina. All warm water getting forced off to the West Pacific. And you need warm water to generate storms to feed the jet stream, because warm water supports evaporation. Evaporation pushes energy up into the atmosphere. That feeds the jet stream, and that feeds the storm track. It is not so much the absolute temperatures, which we saw in the frame above, but it's the anomalies, differences from normal for this time of year. That's what is really the most interesting. You see warmer than normal temperatures here in the West Pacific to, where is that? We'll take a look at the scale right there. 150 is right there, so right there. So it's actually backtracked a little. It was at 150, maybe even at 145 last week, backtracked to 155. No big surprise. Cool temperatures, -3, almost -4 degrees centigrade, filling the entire East Pacific to the date line, and even then west of there. This is the way it's been for weeks now. No change. The good news is it's not getting any deeper, but it's not particularly lightening up any either. A different model using the same data paints the same picture, basically. Warm anomalies making it to, this says 160, and even kind of broken up at that. So basically all warm temperatures, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We'll say 3 degrees Celsius in the far West Pacific, and 1, 2, 3, 4, 5. We'll say 6. 1, 2, 3, 4, 5. And 4 to 5 degree negative anomalies, cool anomalies in the east, the classic La Nina pattern, all driven by strong trades. Sea height anomalies. So this is just a confirmation of what we're getting from the TAO buoy array, but this is satellite based. It's just looking at the height of the ocean, not you take out the waves, take out the wind waves, even take out the tides, and the Earth is a sphere. Is it a perfect sphere? Well, or at least compared to normal, we see that actually there's an indentation here. This is the equator here. This is the date line here. That's South America, Central America, Mexico, New Guinea there. The good news here is, we have a indentation, a broad area of 10 centimeter below normal anomalies. Why is the ocean not as high as usual here? Because cold water contracts, and when it contracts, we know we have cold water at depth, creates a divot on the ocean surface. Notice we have positive anomalies over here in the West Pacific. That's where all the warm water is, right? It expands, creates a bump on the ocean surface. You can literally see like an indentation here. The winds are raging or are pretty solid from the east and have been, driving almost like a point into that warm pool in the West Pacific. Till the trades back off, this will be the pattern, and this is the classic La Nina kind of signal. But we had a broader area of 15 centimeter negative anomalies here. It looks like it's softening up a little bit, but not a lot. Here's yet another view. This is the West Pacific here. This is the East Pacific here. This is upper ocean heat anomalies, upper 300 meters. You can see in April, we had warm water. There's a Kelvin wave traveling from the West Pacific to the East Pacific. And right after that, this was the kickoff to La Nina. Trade started nuking. We got cold upwelling, backed off a little bit in July, really started getting going good in August. This appears to have peaked out in right around the Halloween time frame. That was the coldest spot. And then you notice temperatures generally starting to lighten up. No real motion. And you also notice here warm water building in the west. It still probably has quite a ways to go before the trades collapse and all this reverses itself, and it would do that in the form of a developing El Nino. If that were to happen, it typically happens at the earliest in the late January, February time frame, but in more moderate El Ninos, you can start seeing signs of it as late as May or June. We don't think that's going to happen this spring, but we'll see. But the general thought at this point is, so we're in a, what would you call it, a moderate La Nina. The models had originally said we were going into the strong category, but we're not. We're seeing no data that supports that. We'll get more into that in a second. All right, let's take a look at sea surface temperature anomalies. Differences from normal for this time of year. Blue is colder than normal. Red, warmer than normal. There's South America, Chile, Peru, Ecuador, Galapagos, right there, Mexico. You get the idea. Cold water. In control from deep South Chile, the whole way to Ecuador, the whole way from the East Pacific to the far West Pacific. Now, the news here is, though, see, there's a little pocket of, I'll call it really cold, you see that kind of almost grayish in the middle there. That was filling a broad area here a couple of weeks ago. That has all collapsed. And the depth of the colors here that were definitely a lot darker blue seem to be lightening up, suggesting that for whatever reason, either the trades aren't blowing as hard or maybe this system is already just peaked out. I mean, it's not gone. I mean, this is still a very solid footprint of cooler than normal waters filling the East and Central Pacific, stomping on the evaporation machine and not helping the storm machine at all. That said, we do have rain in California. So La Nina still here, probably not going anywhere, but hopefully past its peak. Sea surface temperature trend for the past 7 days. So last week we got kind of excited because you see the reds here off of Peru and Chile. And from the Galapagos here, it was quite warm here. Now it's getting cold again, meaning trades are trying to pick up again. There's only a 7-day trend. I mean, it doesn't mean it that much one way or the other, but we'd kind of hoped that maybe La Nina was just going to completely die, but this suggests otherwise. Cooling right here in a thin stream and a couple of pockets out to maybe a point south of Hawaii, something like that. So La Nina still trying to do its thing. Here's the backed off view. The interesting part here is right in here is where there was really markedly cold water a couple of weeks ago, back Halloween and even in November. That has all it's much more moderate, less vigorous cooling, doesn't look as nearly as impressive as it did a while ago. And if anything, the worst of it now is more south of Hawaii and out towards the date line. Maybe things are backing off and we're through the worst of La Nina. Sea surface temperature trend in the Nino 1.2 region. This is the areas right there along Peru and Ecuador and the Galapagos. Temperatures, just like we've seen in the other charts, continuing to rise, minus 0.558, so half a degree below normal. The threshold for La Nina is half a degree below normal, so we're clearly still there, and that's not even in this region, but just sort of as a guideline. We went from almost minus 2 degrees in September to now half a degree in December, so that trend is on the right direction. Now the official El Nino monitoring region is the Nino 3.4 region. Temperatures today minus 1.098. Pretty much steady for the entire month of December. This is more out south of Hawaii on the equator, suggesting that La Nina is not dead, but it's not getting any worse. Okay, looks like it almost peaked like November 1st or 2nd, somewhere in there, and now we're just hovering in the what we call the moderate La Nina range. The final index, the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have lower pressure, remember the high pass filter, or the filter in the Central Pacific, suggesting high pressure. Well, when that happens, then typically pressure in Tahiti is higher than normal. The index is positive. Today's value, 16.97. We really want to see this all be in the negative range, but with La Nina, everything's positive. We go back a month here, and you can see it. It's been just hanging consistently positive. 30-day average takes some of the noise out, 10.64. That's pretty positive. And the 90-day average, 8.51 and creeping up, but I mean, it was nearly that a month ago. So I'll say, if anything, holding the same but trying to rise. For a good, strong La Nina, you want to see this at about 12. I don't really want to see that, but that's kind of where we're heading. But remember, the active phase of the MJO is setting up over the next couple of weeks, so that should take some of the positivity out of this and get us, maybe knock it down a little bit. So for right now, still sort of cooking along in La Nina range. Here's the 30-day SOI graphed out. Today's value here, a little bit above 10, maybe 11, something like that. The downward shifts are the active phase of the MJO. The upward shifts are the inactive phase of the MJO. We are in the inactive phase, but we think that this is about going to peak out, and then we should expect to see this trending downward again. But here's the zero line, and we are definitely in the positive range since about July. So again, just another indicator of La Nina. But you know what? This is no more positive than we were back in 2018. That was La Nina as well. And then eventually you can see things crashed. So we'll see where we end up. And then finally, the official sea surface temperature forecast for the Nino 3.4 region. That's the official El Nino monitoring region from the CFS model. Where are we today? Right around here, temperatures minus 1.15, 1.2 in the Nino 3.4 region. That correlates with what we saw. The good news is, I think we've reached rock bottom according to the model. It says we'll hover here into mid-January. The lines here are the middle of the month. And then start a slow warming trend. So originally this model had us down to minus 2.5. This is a definite sort of reality check for the model, but it's sensing it pretty well and saying, okay, we're at our bottom. The bad news is it says we're only going to go back to minus half a degree and hang there in July, almost into August, which is still a half a degree below normal, is still La Nina territory. So La Nina the whole way through the summer, according to this model, unless some miracle happens. And that likely suggests no El Nino in our forecast, and maybe even continuing in some sort of weak La Nina pattern into the following year. Typically, these La Nina things are 2-year events. So the good news is we have swell in the water right now for California and for Hawaii, and there is more on the way. The models are showing a series of, we'll call them reasonably strong gales pushing through the Gulf and then moderating some a week out, but still gale activity. There will be surf, but again, it's the typical La Nina thing. The storm track for the most part is way to the north. The swell angle, therefore, is more north relative to California. A lot of energy focused more in the West Pacific and less in the East Pacific, but, that can change. And again, all driven by La Nina. The longer term out, and also rain and snow for the Sierra. That's good for the snow resorts. If you can do it, everything's pretty much under lockdown, but all the resorts are open. There's no lodging available unless you own a place there or are part of some sort of a long-term program. But you could do day trips, go up there, go ski, go board, and then come home and be safe. All right, the other thing is longer term. La Nina still looks like it's in control, but you saw just how we got 2 major storms out of the blue. Significant run of surf here for a week or so. Now we're starting to fall back into a hole, but the jet stream looks pretty good long term. So it's not unforeseen that the models could wake up. And even more surprising, a potential southern hemi swell is on the charts long term. So La Nina doesn't mean there won't be surf and there won't be snow. But typically the way it works is you get a little window, it happens, and then it's over. So you gotta make hay while the sun shines, as they say. Anyway, that's it for this week. If you enjoyed the video, give us a thumbs up. If you have any comments, please send comments. We try to respond to all of them. If it's something you don't understand, write it there. There's a bunch of smart people that also contribute and could reply to your questions as well. So a good place for discussion. If you haven't subscribed, please subscribe. You get an email notification every time we post the video. If not, go to stormsurf.com. All the data you've seen tonight is available on the site there. And when we post the video, up at the top of each page, there'll be a little link to the video so you can watch it at your leisure. All right, so that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.